Good morning. Today we're going to be starting our statistics unit, and we're going to start this by going over what statistical questions are. So the beauty with statistical questions is it's definitely something you have seen before. It's something you do every day and you probably don't even realize it. So we're going to talk about them, and after the lesson you're going to realize that you ask statistical and non-statistical questions all the time. So, statistical or non-statistical? What is a statistical question? That is a question that you expect will have a variety of answers. So you're going to have multiple answers when you're asking a statistical question. You wish to study the distribution and tendency of those answers. So what does that mean? That means you're going to collect all of that data, so there will be a variety of answers there, and you're going to study it. What does this data mean? How does this affect everybody around us? Is there more of a pattern with a certain response? A non-statistical question is a question that will have a single concrete answer. So you ask a question, you get an answer, that's it. So let's go over some examples, and then we're going to do a practice page for one. Examples of statistical questions. So I have this jar of buttons here in my closet, and I was able to come up with some statistical and non-statistical questions for this jar of buttons. So these are specifically statistical questions because, again, you're going to have a variety of answers here. What is a typical number of holes for the buttons in the jar? So will you typically see 2 holes, 3 holes, 4 holes? Again, you're going to have a variety of answers there. What is a typical size for the buttons in the jar? Are the buttons the size of a dime, size of a nickel, size of a quarter? Are they larger? So again, you're going to have a variety of answers there. How are these buttons distributed according to color? So, do you see more lighter color buttons, more darker color buttons? Again, you're going to have a variety of answers there. So these are examples now of non-statistical questions. So these questions are going to have just a simple, to the point answer. So let's look at an example here. So, how many buttons are in the jar? You're going to have one answer. You count them up, that's it. How large is the largest button in the jar? You're only going to have one answer to that. You take the largest button, you measure it, and that's it. So now, let's play this little game here. Your turn. Which questions are considered to be statistical? So we're going to run through each question, and we're going to put an X if it's statistical or an X if it's non-statistical. How old are you? Will that have one answer, or will that have a variety of answers? Right, so if you said it was non-statistical, you were right. Okay, put an X here. Okay. How old are the students in the school? Will that have one answer, or will that have a variety of answers? Right, that is statistical. There are many different students with many different ages in our school. Therefore, you're going to have a variety of answers. Let's look at the next question. Do dogs run faster than cats? Will that have one answer, or will that have a variety of answers? If you said statistical, you are correct because a golden retriever might be slower than a tabby cat, but a greyhound might be faster than a tabby cat. Let's look at the next question. Does your dog weigh more than my cat? Will you have one answer to that, or will you have a variety of answers to that? If you said non-statistical, you are correct because that's a simple, concrete answer. Does your dog weigh more than my cat? Yes or no? Let's look at the next one. Do English teachers get paid less than math teachers? Does that have one answer, or could that have more than one answer? That is a statistical question, believe it or not. So if you said statistical, you are correct. And the reason being is because that pay rate could vary by age in terms of, are you working in a setting where maybe your English teacher has been teaching for 20 years and maybe your math teacher has been teaching for 2 years and their pay is different. It could vary by state, could vary by if you're in high school, if you're in middle school. So again, that's something you can collect data on and analyze. Let's look at this last question here. Does the most highly paid English teacher at Harvard, so it's a big college, get paid more than the most highly paid math teacher at NYU, which is a college here? So, does the highest paid English teacher at Harvard University get paid more than the highest paid math teacher at NYU? So you're going to take those two teachers, compare their salaries, and that's a simple yes or no question. So that is a non-statistical question because you're going to have one answer for that. So again, these are answers that you're questions, that you're going to ask daily. These are questions that you may be asked. I know we definitely see them at school. So I do want to go over this here, categorical data and numerical data, because that also plays a role in statistical and non-statistical questions. So categorical data, so I'm looking at this right here with this illustration, that is when numbers are collected in groups or categories. So we're still working with numbers, but the sole purpose of their collection is for specific groups or categories. So here's an example. We did a survey based on what types of cars the teachers at MS51 typically drive. And these numbers were collected into groups based on the types of cars that teachers drove. Here's a fun fact. Miss Golette fits into this category right here, purple, because she drives a Nissan. So let's look at numerical data. So I'm looking down here right now. So what is numerical data? Numerical data is information that could be measured using numbers. So we're specifically targeting numbers to measure data. So, for example, we took a survey of students' shoe sizes in one of our classes. We started with size 6 and we ended with a size 10. So by looking at this, we see 4 students wear size 6. 1, 2, 3, 4, 5, 6 students wear size 7. 3 students wear a size 8. 2 students wear a size 9. 1 student wears a size 10. These numbers are our driving force in collecting specific data. So again, if you're not sure about statistical questions, go back, rewatch the video, let us know if you need any help. These are questions that you'll be seeing every day of your life. They're questions you'll be asking every day of your life. So this math really is all around you.